Hello students, myself Geetesh Shinde from Mumbai. I have done my post-graduation in physics with specialization astronomy and space physics from Mumbai University in collaboration with IIT Bombay and TIFR. I am in teaching for past 14 years. I am training to IIT JEE Main, NEET 11th 12th and ICSE 8, 9, 10. Also I have taught to the students of IIT Foundation 8, 9, 10 standard physics. This lecture I am taking for Vedantu. I'll suggest you to download Vedantu learning app and keep learning with Geetesh Shinde. So, students, today we'll be learning the basic concept in physics in a topic known as wave motion. That concept is given by Austrian physicist Sir C.J. Doppler. I am talking about nothing but Doppler effect in sound. So let us understand Doppler effect in sound. You must have experienced that. Suppose you are standing on a road and there is a vehicle in front of you. If it sounds a horn, then you will hear the sound with a natural frequency, because velocity of the sound wave in a given medium is given by a formula V is equal to n lambda, which is a product of frequency and wavelength. So suppose there is an observer standing on a road and there is a truck in front of him. Now, if both observer and truck are stationary, if truck sounds a horn, then what will happen? Observer will hear a sound of natural frequency. That is nothing but the true frequency. Now suppose if the truck move towards the observer, then as it come towards the observer, the frequency of sound will increase. He will find there is an apparent increase in the frequency of sound. That is, this observer will be now getting the more shrill sound. It will be more shrill sound. And as the truck passes away the observer, it moves away from the observer, then this observer will hear a decrease in the frequency. There will be a drop down in the frequency of sound. So, you must have felt this. Suppose you are standing on a road and if the ambulance is approaching towards you, then that sound found to be increasing. That is, its frequency increases. So, whether it actually happens? No, that is called as apparent change in the frequency of sound. Now, why does this apparent change in frequency occurs? That is because of the relative motion between the source and the observer. Now suppose if the observer, in the first case, I have taken this observer to be stationary. If the same observer move towards the stationary source, suppose there is a siren of the mill and the observer, this observer walk or runs towards the mill, then he will find the increase in the frequency. Now, if the same observer, if he moves away from the mill, then the same siren frequency appears to be dropped down. It is decreasing. So, there is an apparent change in the frequency of sound. That is given by Sir C.J. Doppler first. So, that is called as Doppler effect. So, what do you mean by Doppler effect? The apparent change in the frequency of sound due to relative motion between the source and the observer. Please remember, students, there is a relative motion between the source and the observer. If observer and source are stationary, then obviously he will hear only the natural frequency, that is the true frequency. But if there is a relative motion between the source and the observer, then there is a change in the frequency. Either the frequency will increase or it will decrease. That is called as apparent frequency. So how do you define the Doppler effect? The apparent change in the frequency due to the relative motion between the source and the observer is nothing but the Doppler effect in sound. So let us understand Doppler effect in detail with its examples and the equation. So let's see on the laptop what are the equations that we can have for the Doppler effect. Now this is the observer, this is a girl standing in front of the stationary source. Suppose this is a siren. So she will hear the natural frequency. Now this is an ambulance having a siren and it is moving towards a girl, that is listener, then she will hear more frequency. Now let's go to the next case. If the same ambulance move away from this girl, then what will happen? Then obviously there is a decrease in the frequency. Now why does it happen? What I know is when the sound propagates through a medium, it is nothing but alternate crest and trough. You will hear alternate crest and trough. So suppose this is a source, this is a car, and there are two observers here. There is a man here and one woman standing in front of the car. Now what I get is when this car sounds a horn, then there will be the waves propagated in all the direction. Okay, so that will be received by the man as well as woman. Please remember, this source of sound is equidistant from both. Okay, now suppose if the car move towards the woman, then what will happen? Then you will find the distance between the car and the woman decreases. As the distance decreases, what happens to the length of the wave? It also decreases. As the wavelength decreases, the frequency will increase, because what we know, velocity is a product of frequency and wavelength. So as lambda decreases, what is lambda? What is wavelength? A distance between two consecutive crest or trough is nothing but the wavelength. So as wavelength decreases, the frequency will increase to keep the velocity of sound to be constant in that particular medium. But at the same time, this car, as it moves towards a woman, that car is moving away from the man, okay, from this person. So obviously the distance between the man and the car increases. So here the wavelength will increase as the car shifts towards this position. So as wavelength increases, the frequency will decrease. So as frequency decreases, that shrillness will drop down for this man and that will increase for the woman. So this is what the reason behind the Doppler effect, very simply. And now let's understand the equation derived by Sir C.J. Doppler. So you can calculate what is the change in the frequency, what is the apparent frequency. So you can get it as that apparent frequency Na is equal to N in the bracket V plus or minus V naught upon V minus plus Vs. Now what are the terms here? Na is nothing but the apparent frequency. N is your true or natural frequency, actual frequency of the source of sound. What is V? V is the velocity of the sound in that given particular medium. And what is V naught? It is the velocity of the observer. What is Vs, student? It is velocity of the source. Now you will have a different cases. Depending on that, you have to change this formula. I'll list down the cases for you. Remember, any of the case can be asked in your problem. Please remember this. So according to that, you need to choose this. Please remember, it is a ratio. Now you need to imagine yourself in that particular case. Suppose if you consider if the observer is stationary. So if observer is stationary, then you are going to take V naught to be 0. And suppose if the source move towards the stationary observer. So if the source move towards the stationary observer, then what will happen? You will get more louder sound, more louder frequency you will be getting, more frequency you will be getting. So in that case, you will be getting Na is equal to N in the bracket V upon V minus Vs. Please remember, if I take V plus Vs, then obviously my numerator will be less than denominator. So what will happen? So in that case, this ratio, please remember, this is the ratio effect. If that ratio is greater than 1, I am going to get more frequency than natural frequency. If that ratio is less than 1, then I am going to get lesser frequency than the natural frequency. So imagine yourself suppose you are into that equation, in that situation. Suppose you are the observer and the ambulance is arriving at you. That is, you are stationary. So what would be the formula? Your velocity is 0. Observer is coming towards you. So your formula will be Na is equal to N in the bracket V upon V minus Vs. Now suppose if the same ambulance runs away from you, then what will be your formula? Please guess. What is the formula? Na is equal to N V upon V plus Vs. Why? Because here when the ambulance runs away from you, there is a decrease in the frequency. For decrease in the frequency, that ratio has to be less than 1. Remember this in your mind. Imagine yourself in that particular position. You will definitely get the answer perfectly. Whether it is the IIT JEE exam or NEET exam, you will be getting that answer. Now suppose if you reverse this case. Now imagine that you are sitting in a car and there is a siren of the mill. You are moving towards a mill. And as the siren sounds, then you will be getting more sound. So here the source is stationary. Please remember, source is stationary. So in that case, observer is moving. So what will be your formula? Velocity of the source is 0. Vs is 0 in this case. So Na is equal to N V plus V naught upon V. V plus V naught upon V. And if you are driving a car and you are moving away from the mill and the siren hits, then what you will hear? You will hear a drop down in the frequency. The frequency will decrease. So this time, what will be your formula? Na is equal to N in the bracket V minus Vs upon V. Let's see it in the laptop. Let's go for the formula. I'll show the formula. Now this is the formula for which the observer is stationary but the source is moving towards the away from the observer. This was for towards the observer. So it is Na is equal to N in the bracket V upon V plus Vs. And suppose if the source is stationary but the observer move towards the stationary source. So that case, your formula, your apparent frequency will be Na is equal to N in the bracket V plus V naught upon V. And if the same observer move away from the stationary source, then your formula would be Na is equal to N in the bracket V minus V naught upon V. That is what you need to understand while taking the numerical. Please read the numerical carefully. Please see the condition. Now one more thing. If both source and observer move towards each other. Suppose if observer is sitting in a car and there is a truck or ambulance. They both are approaching towards each other. They are moving towards each other. Then the observer, the listener in the car, will hear more shrillness in the sound. So in that case, my formula would be Na is equal to N in the bracket V plus V naught upon V minus Vs. Remember, both are moving towards each other. Now suppose if both are moving away from each other, then what will happen? Which formula I will be using? Quoted in the link. You can write it. Na is equal to N in the bracket V minus V naught upon V plus Vs. So there will be more decrease in the frequency as that of the individual case. One more question to you. Think. Suppose the source is in the center and the observer moves along the circumference of a circle. Then what will be your frequency heard by the observer? I repeat the question. Listen carefully. If source is in the center and observer moves along the circumference of a circle, then what will be the frequency of sound heard by the observer? There is no change in the frequency. Why? Why there is no change in the frequency? Please remember, the source is fixed, observer is moving, but is there any change in the relative distance between the source and the observer? No, there is no change in the distance. Hence, there is no change in the frequency of sound. Because the distance has to change. If distance changes, then only the wavelength will change. If wavelength changes, the frequency will change. So, Doppler effect fails or it doesn't apply in this particular situation. Now, suppose one more case. If both source and the observer, they move in the same direction with the same speed. One more time. If both source and the observer moves in the same direction with the same speed, like this. So whatever the initial distance they will be having, whether that is going to change? No, because they are moving in the same direction with the same speed. Hence the relative distance is not going to change. Hence the wavelength is not changing. Obviously the frequency will not change. And one more case, suppose if observer and the source move perpendicular to each other, then obviously the wavelength is not going to get traced. So as the wavelength is not going to getting traced, obviously Doppler effect fails. So when the source and the observer move perpendicular to each other, then also Doppler effect doesn't apply in this particular case. So what are the examples of Doppler effect in your day-to-day life? Why we are learning this? The example is radar, radio detection and ranging. Aeroplane, to find the exact location of the aeroplane, the radars are placed in the airport, or for submarine, radars are placed. So that is very much important for the ships and the aeroplanes. Or you can find out whether the star is moving towards us or away from us. That is called as Doppler shift, red shift or blue shift. So we can find the position of the star, and we can also find the rotation speed of the sun using the concept of Doppler effect. So I'll suggest you to go through these formulas and we'll solve the numericals. But for that, you need to download Vedantu Learning app and keep learning with Professor Geetesh Shinde. Till then, thank you.